Hello there, hello there. What is up, everyone? What is up? Kidoki. Let's set this thing up. Good evening, Zoran. How are you? Good evening, everyone. I was actually planning to go live like half an hour earlier, but there is a reason why I failed. Yes, yes, yes. I am okay. I am okay. I actually just woke up. That's the reason why I even sound like this. Yes, let's give a couple of minutes to everyone who wishes to join to actually join in. Yeah, feel free to type something in chat. You are already in the stream, right? 3 people. Okay, nice, nice. Waving to new people, Zoran. Yeah, I have a bit more difficult day at work tomorrow, and I need to be already at my client's location at 8 o'clock in the morning. So, I need to get up at 6. And in order to get up at 6 and be the best of myself, I need to, well, properly sleep, right? In order to properly sleep, I need to go to sleep in a timely fashion. In order to do that, we need to do this lesson properly without too much off topic. And that's one of the reasons why I fell asleep a little bit before. I have another hour of rest accumulated. How long is the drive to my client's location? Uh, that's hard to tell. That's really hard to tell actually, because I have no clue where I'm going to park. That's one of the issues. Um, and it's in the center of the city where the traffic is really really high. So I don't know. Could be 15 minutes, could be 45. I really don't know. Really don't know. But yeah, I think going Old Town or New Town. I live in the new part and need to go across the bridge to the old part and then further into the city. Somewhere next to, I don't know if you know my city, but somewhere near Sibona Tower. That's my destination. And finding a parking place there will be interesting. Yeah, I mean, the center of the city is always busy, and especially in the well, basically from 7 something to 8 something. It's a kind of a rush hour, right? So the rush hour is any other, right? So many messages. Okay. So Nobody coming in. I think I'm gonna start with you, Zoran, and whoever else is in the stream because I can see that there is somebody else who didn't type anything in chat, and whoever that is, he or she is waiting patiently. So let's give a reward of starting relatively on time to the person who has actually came here on time. I think that's fair for me to do. Hopefully I will hear Monday, Tuesday that I will be doing a 9 months freelance job. Oh, you applied for a certain job that will take that long? Del Anderson, good evening. You didn't see the notice? Hey Del, do you think, do you use the functionality of YouTube to, you know, when I announce the stream officially through YouTube, do you go to my like a planned video and do you click on it and tell YouTube to remind you when it starts? Do you use this functionality, or do you just rely on your own clock, uh, like when it's supposed to start and just join when it starts? I mean, I am asking because I am um, maybe I should, you know, put my streams earlier, like earlier in the week, so people have a couple of days to click on it. I was just wondering the last announcement. I think I placed it today, so maybe it was a bit too late for you guys to put it today. Maybe for the next Sunday I should do it like tomorrow already, so that you have enough time to, you know, click on it. Iceblade just joins when he joins. That's fair. That's fair. And welcome in. Time change. Oh yeah, I forgot that you have a time change disconnected from our time change. I don't know when we have the change of time. In a month maybe. I think Thursday, Friday is early enough. Okay, okay. I was just thinking that I have placed it, you know, as a video announcement too late this time. Time change is on the end of March. Okay. Okay. I know that we are not at the same date. That's all. I wish they would kill that shit. I don't personally care about which time will they choose. I just want them to stop changing it all the time. That's all. Yeah. Everyone knows it was useful a long time ago, but you know, it has long time not been useful. Imagine telling people in New York that they switch times because of electricity, you know. Habits Die Hard. 7 viewers. It looks like it, yeah. I have actually prepared a video for tomorrow about. I still didn't wake up completely. Sorry about that. A video for tomorrow about virtual machines. And I actually wonder if my video tomorrow will have anything related to what we are going to learn today, because as usual, I don't read these texts up front. Not yet, at least. I don't know. It's not difficult enough for me to actually need to prepare for all of this, and it is kind of interesting to go through all of this with you live and have a couple of surprises here and there. So let's go ahead and see if this lesson today is in any way related to my virtual machines that you're going to get tomorrow. I still didn't do the editing for tomorrow, just the recording. Okay, I think we are going to have. I don't think we're getting any more viewers at this point. Maybe someone will join later, like randomly, but I think that's all we're going to get for the starters. So let's not make people wait too much. Linux as a virtualization guest. Okay, so for those of you completely uninformed about virtualization, the word guest is usually used about the one that is being virtualized, and the host is the one that is hosting the virtualization environment, right? The actual hardware. Zoran is asking, hit the like button. Oh, okay, I'm gonna hit the like button. Give me a second until I find it. Where's the like button? I actually don't have the like button in my command window. Huh. I don't have the like button. I guess only you guys have it. Interesting. Okay. Key knowledge areas. Understand the general concept of virtual machines and containers. Interesting interesting that they crammed both of these in this lesson. And judging by this number, this should be something really easy. Understand common elements, virtual machines in I actually don't know what this is. Could be internet as a service. I'm just joking, but we will see. Such as computing instances, block storage, and networking. Understand unique properties of a Linux system which have to change when a system is cloned or used as a template. Infrastructure as a service, Dale Anderson asks. Well, that actually sounds a lot better than what I said. Understand how system images are used to deploy virtual machines, cloud instances, and containers. Understand Linux extensions, which integrate Linux with a virtualization product. Awareness of cloud-init. Okay, one of the great strengths of Linux is its versatility. One aspect of this versatility is the ability to use Linux as a means of hosting other operating systems or individual applications in a completely isolated and secure environment. This lesson will focus on the concepts of virtualization and container technologies, along with some technical details that should be taken into consideration when deploying a virtual machine on a cloud platform. Interesting. Virtualization is a technology that allows for a software platform called a hypervisor to run processes that contain a fully emulated computer system, right? So once again, for those of you completely new into virtualization, what virtualization does, like in the most simple ways to put it, is it emulates a whole other computer, right? So basically, when you have a proper virtualization host, whether you do it on Windows or on Linux, basically inside the virtualization, let's call it software, you're able to run another virtual computer, and on the virtual computer you're going to install whatever you want. In most cases, you can run Windows, another Linux, whatever. Playing NES on your PC. Well, no. I mean, that's not the usual case for virtualization. That would usually fall under emulation. The hypervisor is responsible for managing the physical. Yeah, the hypervisor is responsible for managing the physical hardware's resources that can be used by individual virtual machines. These virtual machines are called guests of the hypervisor. A virtual machine has many aspects of a physical computer emulated in software, such as systems, BIOS, and hard drive disk controllers. A virtual machine will often use hard disk images that are stored in individual files and will have access to the host machine's RAM and CPU through the hypervisor software. The hypervisor separates the access to the host system's hardware resources among the guests, thus allowing for multiple operating systems to run on a single host system. Commonly used hypervisors for Linux include Xen, KVM, VirtualBox, and those three are mentioned here. Okay, Xen is an open source type 1 hypervisor, meaning that it does not rely on an underlying operating system to function. A hypervisor of this sort is known to be a bare metal hypervisor, since the computer can boot directly into the hypervisor. Okay, this may sound a little bit complex, but we're going to explain it. KVM, the kernel virtual machine, is a Linux kernel module for virtualization. KVM is a hypervisor of both type 1 and type 2 hypervisor because although it needs a generic Linux operating system to work, it is able to perform as a hypervisor perfectly well by integrating with the running Linux installation. Virtual machines deployed with KVM use libvirt daemon and associated software utilities to be created and managed. VirtualBox, a popular desktop application that makes it easy to create and manage virtual machines. Oracle VM VirtualBox is cross-platform and will work on Linux, Mac, and Microsoft Windows. Since VirtualBox requires an underlying operating system to run, it is a Type 2 hypervisor. So, without going too deeply into technicalities, because this lesson is supposed to be a level 1 difficulty, the main difference between Type 1 and Type 2 hypervisors is basically Type 2 is closer to emulating another PC, right? So let's say that you have a software that you install on your operating system, and this software emulates another PC, and then it runs another operating system inside your own operating system. This translation, these two steps from your hardware to your operating system to the application that is doing the virtualization, and then further on to the virtualized guest operating system. So you're basically running two operating systems. This is basically a Type 2 hypervisor because it is slower to emulate on a PC that runs another operating system than it is for the actual hardware to run the operating system directly, right? But there is also a Type 1 hypervisor, and this wizardry, literally wizardry, is what enables Linux to basically pass through your guest operating system, the one that you are having virtualized, it enables it to access your CPU directly, as directly as possible, like through the through your host operating system, right? I said that I'm not going to make it too complex, but generally, when you see type 1, this means fast, and when you see type 2, this means slower. So that's the general difference, right? That you really want to remember for the beginning, and later on you're going to understand a bit more into details how and why. Iceblade says didn't know what KVM was. Del Anderson says type 1 and 2 at the same time. Don't understand. Either it's bare metal or not. Del Anderson, you're correct. Either it's bare metal or not, exactly. So it's not both at the same time. It is the fact that it can be one or the other. Depends on how you set it up. That's the difference. Del says, doesn't type 2 take up my RAM due to host as well? I don't understand the question. What does it mean, take up my RAM? I bet the rest of the lesson will explain some things, but we can go ahead and talk about it for as much as I know. Type 2 is the host running as well in RAM. Yeah, exactly. But it well, the trouble with KVM is that it always runs Linux, right? So the host is eating your RAM already at the start. And if you run a type 1 KVM, then it means that both the host and the guest are eating your RAM, right? And this is the same as with type 2. So in every case, the virtualization software, how do I put it? Let's say that you have a VMware ESXi virtualization software. So that product is served only to virtualize virtual machines, right? And this is a type 1 hypervisor. But by itself, it is also eating your RAM, because something needs to boot up in order to enable your virtualization. So the virtualization software always has some kind of underlying operating system. It's just that in this case, you usually have an active Linux installation that can be used for other things as well, and not just for virtual guests. Zoran is asking, any virtual machine will use your physical RAM or... Oh, that's not a question. Okay, that's a statement, yeah. Yeah, any virtual machine will use your physical RAM or CPU or disk. Dell says, I ask because I like lean for cheap machines. Wonder if type 1 would use less host resources. Well, the type 1 usually has the ability to provide the guest with more, I need the word, more direct access to the bare metal hardware. It's just that it's not lean. It's just more direct and more performant. I mean, nothing is really stopping you from using KVM type 1 virtualization, for example, on Debian, without installing everything else that you usually install on Linux, right? You can install minimal Debian with almost nothing on it, and just install KVM, virtualization software, right? And simply use it. Simply use Debian to act as your virtualization host and nothing else. And this will be as lean as it can be. No. There is no hypervisor that can unload itself. It must be running at all times. Let me show you what I have been working on this weekend. Okay, let me show you this. I will try not to dig too deeply into this. This is an application called Virtual Machine Manager, and I am running this application on my computer, which I'm using currently for streaming, right? So my main PC, my main Arch machine. And so I am connecting with this GUI to my remote server, which is actually running a virtualization software, which is KVM, as you can see here. I hope it's not too small. The text is not too small. It says QEMU/KVM, and there is an IP address of the virtualization server, right? And you can see the host CPU usage. It's about, I don't know how much that is, 5%. And you can see the CPU usage, which means the guest CPU usage. And I have installed Pi-hole, right? And well, let's open it. I don't think that you will be able to see this. It is really tiny. And I also don't think I can, maybe I can increase the text. Let me try. The category configure. What was the Debian's what was the Debian's package for text console? For the text console, let me check. To change the fonts. I'm gonna find it any second. I used it a couple of days ago, but I forgot the command. Forgot. Console setup. Okay. Okay, let's console setup. Where is UTF? Awesome. Latin 2. Go with Terminus, if it's even installed. Go with the biggest font there is. Okay. Those buttons are humongous. Yeah, they just appeared like that on their own. I have no clue why. No clue why. Anyways, I just wanted to show to the rest of the chat. So where am I at the moment? So this window is literally a window into my virtual machine that is running on the host 99.10. Okay, so let me show you 99.10 IP address. So you can see here, this window is my SSH into my 99.10, which is my virtualization host, which is also Debian. I actually forgot all of the commands because I'm still kind of learning this, but wish list all. Okay, why isn't it showing It's not showing my root. Okay. Okay, let's do it like this. Is this the sh? I think it is. Cat dot the sh history app list. Okay. We need, I guess, this command. Yeah, okay. This is with root access. So basically, we have one virtual machine running on the host that is, well, as I said, my remote host, a Debian server, right? It is running a virtual machine that I have named Pi-hole. And if I remove this from the screen, then you can see me remotely connecting into my Pi-hole machine, right? So let's type, actually, let's go back to the host. Let's do the htop here, right? So in the in the host, the one that is hosting virtual machines, you can see that the host is using 1 gigabyte roughly of RAM, right? It is running 1 gigabyte of RAM, and the CPUs are doing almost nothing, and the load average is 0.07. So everything is basically idling, and you can see with the green font here that we have some QEMU systems running. And if I remove this, and if I run htop on the virtual guest, the one that is being virtualized, right? You can see that we have, you cannot see my mouse properly because it vanishes when I enter the space for the virtual machines. But you can see it says 114. So roughly 100 megabytes of RAM is actively being needed for this virtual machine to run, right? So this is Debian with Pi-hole software installed, and altogether it is using 113 megabytes of RAM, right? And I have given the entire machine, well, I told it to have 512 megabytes, but maybe something went for the graphics card. I can tune that later, but roughly half a gigabyte of RAM is applied to this virtual guest, right? So this guest is on the IP address you can see here 99.15, right? And this virtual guest is running also inside my LAN. So this is basically my Pi-hole server. NeoFetch? No, you don't need NeoFetch. It's not even installed. Zoran, you cannot use Control X in the TTY. This is literally being logged in locally into the computer. It is a virtual computer, but we are like with a local keyboard simulated or emulated, right? We are in VT1, I think. But also you can do it like this, right? We are now back on my main PC, which from I am streaming, right? We can do SSH. Okay, so the .15 is my virtual guest, right? The one that is running Pi-hole. Okay, we can just remote into it directly from here and see what's going on like this, right? Without needing to log into it locally. Also, maybe this demonstration will help you to get a better understanding, or to get a little bit more feelings about it. Let's do it like this: sudo power off. You know what this command does. So Okay, the machine name is Pi-hole. Okay, and basically we have now powered the machine off. Ping 99.15. Okay, so you can see it's no longer responding because we have literally powered it off, right? And now let's go back to our remote window into virtual machines, right? Actually, not that one. We want. Where's my? Oh, there we go. So this is virtual machines. It says Pi-hole shut off, and let's ping this some more. Okay, you can go and press play here. Power on the virtual machine. You press play, and it says the virtual machine is now running. And pay attention to the ping command below on my PC, right? So what is happening with the guest now? It is booting up, and below you can see that it is now replying to the ping, right? So the machine, the virtual machine, the virtual guest was completely powered off on a completely different server, not on my PC, and now I have ordered it to wake up and start. Basically, I have powered it on, and now it works. This is, of course, the simple way to show it, but what I wanted you to get a feel of is what virtual machines behave like. You know, you can power them on and off remotely. If you actually, let's do this. Let's do one more thing. Let's connect to the virtual machine. Sudo -i. Okay, we have 99.15 address, right? And that's how we have connected to this machine, by doing the SSH into the server, right? Into the guest server. Let's do the system control stop network or networking. Okay. So what I did now, I have stopped networking on a remote server. And the reason why my prompt is frozen is because I have done this remotely, and I have literally cut off myself from the server. I can no longer communicate with this server because the server has its entire networking stack down. It is no longer on the network, right? And the only way to fix this is by going up to the server physically, plugging in a monitor and a keyboard, and typing the command system control start networking. And you have to do this physically on the server. But considering that this is not an actual physical server, but a virtualized guest, the way we can do the keyboard and monitor thing is by using this window here and selecting the Pi-hole server, which is still running. It's just that its network is dead. And you click open, and voila, we have now used the keyboard and monitor thing locally on this server, which currently has no network. System control start networking service. Voila, networking service has now been started. And look, it's working again. Amazingly, my SSH session actually survived for a minute or two without being broken. Let me catch up with chat. I think I demonstrated everything I wanted to demonstrate because I just wanted you to have immediate understanding of what virtual machines behave like. Zoran says, I'm running Pi-hole natively on my Ubuntu. What is the advantage to run Pi-hole as an example in a VM? What is the advantage of running Pi-hole as a VM? Okay, I will tell you exact reason why I did it like this, because there is a certain advantage to this, but you have to have a specific needs. So when you install Pi-hole will install also its own web server, and it will take some of your ports, etc. Right? So what I want to do at home, I want to install Pi-hole server. I want to install the PeerTube server. This one needs web server as well, and by default it will use Nginx, and this one is using its own web server. So already we have a problem of running two web servers of different kind on the same server. So this can be mitigated by using different ports for the web service, but it is getting slightly complicated and still manageable. Then I want to run maybe a Mastodon server. I haven't decided just yet if I'm going to move my Mastodon server to my own server here, but it is costing me a lot of money per month to host it elsewhere. So I might move it to locally, right? And Mastodon also runs its own web server. Now we have 3 web servers on the same host and probably 3 different web servers. I'm not sure which web server binary is Mastodon using, but even if it's Nginx, this is getting slightly complicated for maintenance later on, because when you're maintaining the software, you have to be careful about maintaining it in a way that this service is expecting you to do, and also this service is expecting you to do. I'm also going to run Nextcloud on the same server, literally. So more web servers, more databases in the background. This one is using not just Postgre, but also what's the name of the database that runs entirely from the RAM? Redis. This one is also running Redis. So I am stacking up a lot of servers, and by servers I mean services, and each one I'm going to add more of them. Don't think I won't. There will be like 6 or 7 different services. Maybe even a server for, I don't know, Jellyfin for watching movies, and some more. Maybe even Minecraft. So at the end there will be like 10 services that are going to be very difficult to maintain if they are installed on the same operating system. It is simply getting too complicated to maintain. So how you can deal with this is by putting each service into a container, or by putting each service entirely isolated in a virtual machine. And I have been hopping on and off between thinking about how I want to separate all of these services, whether with containers or with virtual machines. And I kind of decided that virtual machine is easier to maintain because every service will get its own operating system tailored for the exact needs of this service. Because, let's say PeerTube. PeerTube needs what is it called? The thing that comes with the npm command. I forgot. But anyways, for PeerTube, I need to install some software that is not provided with Debian 12, and I have to use some third-party repositories to fetch what is needed. And I hate to do that on a system which hosts other services, because when you install a lot of third-party stuff, things tend to get broken. So I simply decided to host everything on virtual machines. And the best part of hosting virtual machines is that you can have, let's say, a second server later, and you can just migrate the virtual machine to the second server if there is no more room on the first one. You can just migrate one machine or all of them to a second server. Really easy, right? Iceblaze says, but you can send a power on command from console and only the manager. I have no idea what you mean by that. Dale Anderson, what does Pi-hole do? Says ad blocker on their website. And is it a Docker image? Not clear if it's a virtual router or server or something else. No clear data on the page what it is. Dale Anderson, if nobody answered your question, Pi-hole is DNS server, basically, which blocks access to certain websites, and certain websites being basically the websites that serve ads. This is the Pi-hole interface software that I have installed yesterday, I think. So since yesterday, it has blocked 5,000 DNS queries. And if you list blocked queries, you can see which websites were unable to resolve thanks to Pi-hole. S.Amazon ads system, Video Edge Live something, Google Ads, Mask something iCloud. Go to second page. Pinterest something tracker, I suppose. Static double click. Firebase logging, Google APIs. Okay, so that's pretty much what it does. So nothing to do with Raspberry Pi, Del Anderson says. It started as a project that was ideally suited to be running on a Raspberry Pi. That's the reason why it's named like that. But you can install it to whatever you want. Up until yesterday, I have actually had Pi-hole installed on my Raspberry Pi 2 because that one has plenty of power to run Pi-hole. Iceblade says you're basically there but remotely. Exactly. Zoran says Pi-hole is a black hole for incoming ads. It can run in a container, VM, and natively on a server. Yeah, I have it natively on a server, but yeah, it can run in a different ways. It can act as your DNS and DHCP. Not that it can act as your DNS, but it has to act as your DNS. That's what its task is, to be your DNS. Zona says port 18 and 443, and it runs FTL. You can configure FTL to use different ports. Of course you can, but I'm not talking about combining Pi-hole and PeerTube. I'm talking about combining 10 different services, and each service needing a different web server, a different database, a different libraries, different versions of libraries, third-party repositories for Debian, a lot of modifications to the host system. It is really getting very complex to maintain. And sooner or later, you are going to break your system. And once you break it, you're going to break it for all 10 of your services. That's the problem. That's the challenge that this is solving. So what I'm doing is when I have to maintain only one service on a server, then I do it per the instructions that the maker of the service tells me to do. I dedicate the entire server to just one service, and I do it exactly as the maker tells me to do. This is how I avoid a lot of headaches by doing things, let's say, my way. And I cannot hurt, even if I break something on the server, it will not break my other 9 servers because I have 10 servers. You know, I only have one physical server, but I have 10 servers, you know, for 10 different services. I simply decided to separate them like that, and I think this is a good way to do it. It's not the best way to do it for every scenario out there, of course, but for my scenario, I think it is good. Containers could also do the job. I kind of prefer virtual machines. I was thinking about containers. I just decided that this is easier to maintain. Zoran says uses webmin on port 10,000, Ubiquiti, Pi-hole, all on the same machine. Yeah, fine. I'm not saying it's impossible. I'm just saying that when you install from the third-party repositories, things can get messy. Zoran is asking, what about using Proxmox? Yeah, what about Proxmox for all your servers and services? What do you mean, what about using Proxmox? Is it a question like, why did I choose Debian and not Proxmox? Or what is it that you're asking? I mean, Proxmox is also Debian, just with an interface. So do I really need the interface? That's the question. You're going to need a network atlas to keep track of things in 3 months. You'll forget how all it's set up. I actually don't think that's the case, because I have made it as easy as I can for myself. I know which server is on which IP, and that's basically everything I need to know. And yes, you are right. When I install FileCloud, it did something to my Pi-hole, so I had to install FileCloud into a container. Demlan Trap said, welcome in Demlan Trap. I use Pi-hole also. It's very cool stuff to have on your network as DNS server. Yeah, it's practical. Yeah, yeah. Mark Carpenter, welcome in. Morning, everyone. I believe you can also redirect traffic intended for one website to another website. Pi-hole can easily run on Raspberry Pi. Yeah, for the last year or more, Pi-hole has been running on my Raspberry Pi 2. So Raspberry Pi 2 is plenty powerful for that. How much RAM do you give to each virtual server? I give it as much as it needs. That's the most honest answer I can give you. If the Pi-hole server runs with less than 150 megabytes of RAM, then I just casually give it half a gigabyte of RAM, just to be sure that it can breathe for as much as it likes. Why did I choose Debian and not Proxmox? Well, yeah, I want to learn things. That's the reason why. I want to learn how things work. Going with the GUI stuff that does things instead of you, in my opinion, in my personal opinion, this is a bad way to learn. The GUI that does too many things for your convenience by just clicking on icons is really practical for maintaining a complex network. But I think this is a good idea later, in a later stage, after you have learned how it ticks under the surface. I think Proxmox is good for professionals, who know how things work. If you start with Proxmox, then there is a good chance that you're not going to understand how this actually functions under the hood. This is what I want to avoid at all costs. I'm not saying that I'm not going to switch to GUI later. It's just that for the beginning, I really need to understand how everything works, and I want it to break under my fingers. I actually want it to break, because when I break something, this is the best opportunity to fix it. When you fix it, then you understand why it broke. If you're running a GUI which is made by professionals for your convenience, you're never going to break it. You're never going to need to fix it. You're never going to learn how it works. So, to some degree, you will learn. But I really believe that configuring everything manually from the command line is the absolute best way to understand how the thing works. Because all that Proxmox does is basically the same that I'm doing, but in a clicky automated way. I didn't mean when something breaks. I meant when I break something. There is a difference. Things don't usually break on their own. Okay. Some hypervisors allow for the dynamic relocation of a virtual machine. This is exactly what I was talking about. The process of moving a virtual machine from one hypervisor installation to another is called a migration, and the techniques involved differ between hypervisor implementations. Some migrations can only be performed when the guest system has been completely shut down, and other can be performed while the guest is running, called a live migration. Such techniques can be of aid during maintenance windows for hypervisors, or for system resiliency when a hypervisor becomes non-functional and the guest can be moved to a hypervisor that is working. Actually, Dale Anderson, I think you asked me why or not. No, Zoran asked me why. Uh, One of the reasons why I'm not running Proxmox is because I actually want to use my Debian host for some other things. Not that you can't do it on a Proxmox, but it is advisable not to touch it. Types of virtual machines. There are three main types of virtual machines: the fully virtualized guest, the para-virtualized guest, and the hybrid guest. The fully virtualized guest. All instructions that a guest operating system is expected to execute must be able to run within a fully virtualized operating system installation. Okay, Iceblade. I really don't mind. I know that you're going to catch up one way or another. Iceblade here is, in my opinion, the most hardworking student on the entire chat. And by that, I don't mean that he knows the most out of every one of us. I'm just saying that he works the hardest, in my opinion. like invest the most energy to catch up with everyone else. No, I'm just giving him how do you say it in English? Like good. Uh, you know, how do you say it when a teacher gives a positive word for somebody's efforts? Kudos. Yeah, I meant kudos, but I wanted to use the word that is officially used in schools or something like that. Teachers definitely don't use the word kudos. Encouragement, compliment, positive reinforce, praise. Yeah, praise sounds the closest to what I meant. Because if you take a look at my previous live stream recordings, you will mostly see on each one of my videos a reply from Iceblade, usually a day or 2 or 3 days after the stream. You will see a reply from Iceblade who says that he rewatched the entire stream, and after rewatching it, he got a better score on the answers at the end of the lesson than he did when this was live. And you can see him replying on each one of my videos, and only him. Literally, only he does that. So at least I can see that he is rewatching it and trying his best to do what he can. Zoran, yeah, I meant pohvaliti čovjeka. But yeah, we already managed to find the word. Anyways, all instructions that a guest operating system is expected to execute must be able to run within a fully virtualized operating system installation. The reason for this is that no additional software drivers are installed within the guest to translate the instructions to either simulated or real hardware. A fully virtualized guest is one where the guest or hardware VM is unaware that it is running virtual machine instance. In order for this type of virtualization to take place on x86 based hardware, the Intel VTX or AMD V or 5 CPU extensions, this is V actually, CPU extensions must be enabled on the system that has the hypervisor installed. This can be done from a BIOS or UEFI firmware configuration menu. So if you're running full virtualization, I believe that each one of you have seen these in your BIOS at some point. So you need to have these on in the BIOS. A para-virtualized guest or PVM is one where the guest operating system is aware that it is running a virtual machine instance. These types of guests will make use of a modified kernel and special drivers known as guest drivers that will help the guest's operating system utilize software and hardware resources of the hypervisor. The performance of para-virtualized guest is often better than that of the fully virtualized guest due to the advantage that these software drivers provide. Para-virtualization and full virtualization can be combined to allow unmodified operating systems to receive near-native input-output performance by using para-virtualized drivers on fully virtualized operating systems. The para-virtualized drivers contain storage and network device drivers with enhanced disk and network input-output performance. Virtualization platforms often provide packaged guest drivers for virtualized operating systems. The KVM utilizes drivers from the Virtio project, whereas Oracle VM VirtualBox uses guest extensions available from a downloadable ISO CD-ROM image file. So basically, if you're running a KVM and another Linux inside the host as a VM, there is a good chance that it will come out of the box with all of the Virtuo drivers already in place. If you're running Windows as a guest inside your KVM on Linux, then you're going to have to go to Fedora website, I think, where you need to download Virtuo drivers for Windows. Because if you don't download those, Windows is not going to function properly. It will boot up, but it will not function properly until you give it all of the drivers required to run on this kind of hardware. And by this hardware, I mean this. Do I have a mental image on how this works so I can remember it? I am not actually sure about para-virtualized. I'm not actually sure because para-virtualized. Sorry. I meant I thought that you were asking about hybrid. Hybrid is what I don't understand. But let me try. Let me try this. So here we have Pi-hole. Let's open Pi-hole, and let's go to the configuration of this computer. Okay. So Pi-hole computer is running KVM hypervisor. It is running x86 architecture. On KVM QEMU, you can actually change the architecture to something that is non-x86, but let's not go into this complication right now. Chipset Q35, whatever, from Intel, old stuff. Firmware, so this is the BIOS. I have told it to use the UEFI BIOS. This computer, right? You can switch to old BIOS if you want for this computer, but I wanted to have UEFI. CPUs, I have given it one virtual CPU, literally one. Let me just show you. See, on the top above the memory, you have one CPU, one core, no hyperthreading, no nothing, just one core. This is perfectly fine for Pi-hole, and I don't want to bother the host with sharing too many resources with a machine that doesn't need it. Host pass through, okay. Memory, this is where I have assigned half a gigabyte of memory. You can enable shared memory. I just don't like to do it because I don't have enough experience with this kind of thing. I'm afraid that this is going to break something while I'm not fully understanding how it behaves. So I just assign a fixed amount of RAM to the guest, and as soon as the guest powers on, the host loses this amount of RAM immediately, and this is fine for now. Boot options, we're booting from Virtuo Disk 1, and Virtuo Disk 1 is the type is Virtuo. This is the type of a hard drive controller, right? You need to have drivers for this kind of a hard drive controller, and this is your cue why this is para-virtualized. So we are not emulating an existing hard drive controller from Intel or Realtek or something like that. We're giving the guest something called Virtuo controller, and this actually requires special drivers in order to function. which are included in Linux, but not in Windows. Network card. So see here, also a Virtuo type of a network card. So once again, for this card, you need to have Virtuo drivers. But of course, you can use Intel 1000E network card. This is a really, I was about to say popular, but not popular. This is a widespread, older type of network card that is well supported across many operating systems. And it is one of those network cards that just works literally everywhere. So you can use this kind of a network card, but I don't need it. So I just use everything in Virtuo mode. PS2 keyboard, PS2 mouse, display server, right? So you can use the graphics card of Virtuo type, right? But you can use a regular VGA card if you want. QXL is also available and stuff like that, right? USB controller. This is a pass-through thingy. USB. Actually, this is a pass-through thingy. What else do I have here? Serial. Sound blaster. Yeah, that's pretty much all. So if everything would be like real hardware, that would be like full virtualization. But since these offer better performance because they are more tightly integrated, basically, how would I put it? The KVM, when using its own Virtuo type of hardware, is able to more efficiently pass through your hardware. And if you would run a fully virtualized guest, then you would have to emulate actual hardware, which is not really in your host. So basically, the fully virtualized guest would have to use an emulated hardware. I think that's the best answer I can give. Mm, 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 mm. I'm trying to catch up with chat, but I'm not sure what's a question for me or what's just a chat. Are these drivers there are to simulate the hardware, similar to the way Wine adapts Windows to run on Linux? Don't use Wine in this context. Wine is something completely different. But when you tell the virtual host to emulate an existing physical hardware, then this is fully virtualized. What I showed you is with that Intel 1000 network card, that would kind of fit in here. And using Virtuo drivers is what fits in here, because Virtuo drivers are designed to not force the host to emulate a different kind of hardware. I'm getting near the edge of my abilities to talk about this topic, but I'm trying as far as I can. Dale Anderson, you got it right in the first sentence, but the last one, I think that is how guest additions work. What is additions? Basically, the full virtualization will make the guest not even realize that it is running anything else than an actual machine. But in order for this to happen, the host needs to emulate hardware. That's what slows it down a little bit. I don't have experience with VirtualBox. I kind of tend to use what Linux offers natively, and for the past couple of years, I was using Linux at work. Um, so I need Windows for some of my tasks. Sometimes I just need to have them. And I'm running QEMU KVM on my laptop to have these windows available for me when I need them. So, as I said, I tend to use what Linux offers by default. Not that I dislike VirtualBox or anything. It's just that if Linux comes out of the box with everything that I need, then I have no reason to search elsewhere for a solution that Linux already is giving me. So I can't talk about VirtualBox. No experience there. Okay, example libvirt. I think we need to find pictures or diagrams that show where the translation happened. The outcome is similar but possible efficiency differences. Let's see if there are some pictures here. No pictures here, just a lot of code. Is this a good question? Daimler Trap, are you using Virt Manager as GUI? Yeah. Uh, Here it is. Virtual Machine Manager version 5, powered by libvirt. Fully virtualized VMs is like a... Okay, I may have overdone it with a question. Ahmed Nasser, welcome in and greetings. A fully virtual VM is like a toy car that can run on any track without needing to know it is on a track. It thinks it is running on real roads. The hypervisor, the track, does all the work to make the car think it is on real roads. This means the car, the VM, doesn't need to be changed to know it is on a track. It just runs as it would on real roads. This is why fully virtualized VMs can run any operating system without changes. A para-virtualized VM is like a toy car that knows it's on a track. The car has been specially made to work with the track. It has special parts that let it communicate directly with the track to make things run faster and smoother. This means the car VM needs to be changed a bit to work well on the track. But because it knows that it is on a track and can talk to the track directly, it can run faster and more efficiently than a fully virtualized car. I actually don't think that this is a bad answer. I mean, I asked him to make it like this, but it's actually fine. Good answer. In a fully virtualized environment, the virtual machine runs unmodified operating system. It believes it's running on real hardware. The hypervisor has to do a lot of work to make this illusion possible. Instruction emulation. The hypervisor must intercept and interpret certain instructions that the operating system sends to the hardware. This process, known as binary translation, can be computationally expensive. Input-output operations, like reading from a disk or sending over network, are often more complex and slower because they involve multiple layers of abstractions. In a paravirtual VMs, the operating system is modified to be aware that is running in a VM. This allows for more efficient communication between the VM and the hypervisor. The key benefits include direct communication. The paravirtualized OS can use special interfaces to communicate directly with the hypervisor. This reduces the overhead of emulation and binary translation. Okay, so this is the term that I used. Optimize the input-output operations because the operating system and hypervisor can coordinate more effectively. For example, the hypervisor can batch input-output requests or use more efficient data transfer mechanisms. Reduced context switching. The hypervisor can manage resources more efficiently, reducing the number of context switches. The processes of switching between different tasks and improving overall performance. Network. The VM sends a network request with which a hypervisor must then translate into a form that the physical network adapter can understand. This involves extra steps and can introduce latency. While in paravirtualized, the VM uses a paravirtualized network driver that can communicate directly with the hypervisor. The hypervisor can then more efficiently handle it. Many modern virtualization solutions use a hybrid approach, combining the benefits of both fully and paravirtualized VMs. For example, a VM might run an unmodified operating system, but use a paravirtualized drivers for specific tasks like network and disk I/O. This approach provides the flexibility to run any operating system while still achieving good performance. We good so far? The answer was clear. It clarified that para or full applies to the VM hypervisor capabilities and therefore also the increased requirements placed on the guest by non-fully virtualized VM. Iceblade says, I don't think Docker works like a VM, more like it has real files in different versions in the same box, so not to replace or use your current files on system. Demlen Trap asked, are containers like Docker also some kind of virtual machines? No, containers are not virtual machines at all. Containers are just like, actually, Iceblade gave it a really good explanation. A container is when you use the existing machine, an existing operating system, right? And you simply replace some of the file paths for different file paths. You just in a very, very simplified way of speaking, you tell your installation like, sure, use our existing RAM, use our existing hard drive, use our existing CPU, use our existing kernel, use all of the existing hardware that is already being in use. So don't emulate a new machine. Just use the existing machine, but your etc folder, your user folder, your home folder, your lib folder are no longer there. They are now here. You use this file system instead. That's the container. So the container behaves like it's a different operating system, different Linux. It cannot be Windows. It must be Linux. So the container behaves like this is another Linux, but it's using all of the resources, all of the hardware resources of the one from where it is being started. So it's like I'm trying to find a good analogy, but it's just a container for files. Yeah, something like that. But it's not just a container for files. You can trick it into thinking that, for example, you're using Debian operating system, and on Debian you make a container and you put Arch Linux inside the container. And by Arch Linux, I mean everything that makes Arch, but it is still using your Debian kernel and RAM and hard drive. But it has Pacman file manager, package manager inside the container, and it can actually install packages for Arch inside the container. But it is still using your own kernel and your own RAM and your own hard drive and your own hard drive space. But it has some kind of I wanted to say forked file system, but it kind of thinks it is Arch Linux. You can put Fedora as well, or Ubuntu, whatever it's already prepared. Someone needs to prepare it as a container. I actually think I have one running right now. What is the command? Plus, okay. Okay, this is a container that I am running. So it's a bundle of dependencies and applications. Yeah, that's pretty good. So on my Arch Linux, I have a container called OpenWebUI. This is a software that is used for how do I say it? For running a ChatGPT like web interface for your locally run large language models. And the way that OpenWebUI Maker is giving you their application, their software, is by giving you the entire container, which you can run on any Linux. And the reason why they do it like that is because they have a lot of dependencies on the operating system, which they were, let's say, unable to make it simple for the installation for the end users. So they just give you the entire operating system inside of a Docker container and tell you just run it like this and don't touch it. It will work, just don't touch it. And a lot of developers of the software lately are doing exactly that, right? They rely on a certain version of the library, and if you have a different version of the library in your operating system, then their software might misbehave or something. So they give you everything that is required inside one box. Docker run open web UI. I think that's the command. Or login. Why is this denied? I can't remember all of these commands when I don't use them frequently enough. Is this the command? I guess not. Oh, shit. Did I just shut it down? I just killed it. Oh well, I just killed my Docker. Never mind. Yeah, let's not do too much Docker. It is a part of this lesson, but this lesson is supposed to be easy. Goody. We example libvirt virtual machines. We will look at an example virtual machine that is managed by libvirt and uses the KVM hypervisor. A virtual machine often consists of a group of files, primarily an XML file that defines the virtual machine, such as its hardware configuration, network connectivity, display capability, and more, and an associated hard disk image file that contains the installation of the operating system and its software. Okay, so once again, Pi-hole, open, information, XML. So this is exactly what this description is saying a virtual machine often consists of a group of files, primarily an XML file that defines the machine, right? So this is the XML file that actually defines this machine, right? First, let us start to examine an example XML configuration file for a virtual machine and its network environment. ETC libvirtqemu. Networks Red Hat Enterprise Linux 8.0.xml. The following was the command to run OpenWebUI in my environment. Zoran is still on containers, because why not? I think this is the most interactive classroom I have ever participated in my entire life. And nobody is complaining about the constant derailment. Literally nobody. Zoran, you have a big gap between your semicolon and whatever is coming afterwards. Big gap in time. Yeah, and anyways, let's examine an example XML configuration file for a virtual machine and its network environment. So list in the etc libvirt qemu. So this is exactly what I did on my end, and we can open my Pi whole configuration. Nice. So this is my Pi whole configuration here. We're not going to read it immediately, but let's go with the lesson. But just know that I have it prepared. They have prepared Red Hat something. The QEMU portion of the directory path refers to the underlying software that KVM-based virtual machines rely on. The QEMU project provides software for the hypervisor to emulate hardware devices that the virtual machine will use, such as disk controllers, access to the host CPU, network card emulation, and more. Note that there is a directory named networks. This directory contains definition files, also using XML, that create network configurations that the virtual machines can use. Let's check it out on my end. Yep, networks bridge. Yeah, so this is my bridge configuration here. My networking. This hypervisor is only using one network, and so there is only one definition file that contains a configuration for a virtual network segment that these systems will utilize. So list QEMU networks, auto start folder, and the file default.xml. In my case, it is bridge.xml. So the configuration of this network that they are using in the lesson, it's called VIRBR0. It's of type NAT, network address translation. It has an IP address. It has a DHCP server, and etc. Right? This definition includes a Class C private network and an emulated hardware device to act as a router for this network. There is also a range of IP addresses for the hypervisor to use with the DHCP server implementation that can be assigned to the virtual machines that use this network. This network configuration also utilizes network address translation, NAT, to forward packets to other networks, such as the hypervisor's LAN. So, for those of you who don't know what network address translation is, in the simplest, the XML file looks like code, but what language? The language is called XML. Network address translation is a kind of a network where your guests are not bridged in the same network where your host is, but rather the guests are behind your host, and your guests can usually only talk to each other and with the host and nothing else. And then the host acts as a NAT router to let the guests go through the host routes the guests outside into the rest of the network, right? But since it's network address translation, when the guests routes through the host to whatever, then it goes outside with the IP address of the host and not with its own IP address. So if you want to connect to the guests from outside, you cannot. There is a way, but in the most simplest terms, you cannot connect to the guest. So network address translation is not always convenient for servers. Yeah, I just remember that one of my virtual machines that I'm going to install will be a Home Assistant. But yeah, I have a lot of them in my head that I want to install. We read some part of this. This definition includes a Class C private network and an emulated hardware device to act as a router for this network. There is also a range of IP addresses for the hypervisor to use the DHCP server implementation that can be assigned to the virtual machines that use this network. This network configuration also utilizes network address translation to forward packets to other networks, such as the hypervisor's LAN. Now we turn on attention to our Red Hat Enterprise Linux 8 virtual machine definition file. Sections of special note are in bold. Okay, let's see the XML configuration for this virtual machine. Domain type is KVM. The name of the machine is whatever we have chosen. We got some ID, some metadata here, memory unit for what is this, gigabytes? 4 gigabytes, virtual CPU placement, 2 CPUs static. Architecture, x86, Q35 chipset, on reboot restart, on crash destroy, on power off destroy, la 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 la. Disk file type is one file, device equals disk, driver name QEMU, type QCOW2. So this is this exact same type that I'm using. I'm not even sure there is another type, for the disk file, but it is what it is. Source file where the image is located, right? Actually, let me show it to you. Okay, so on this path on my server, I have two files. You can see here Debian installer ISO image is 600 megabytes, and the Pi-hole QCOW2 is 34 gigabytes. Okay, and the reason why it is 34 gigabytes is because I have given it, basically it's 32 gigabytes, but it is in bytes, right? Basically 32 gigabytes is the size of the hard drive that I have given it. But if you type df, you can see that my partition called Quattro is used 3, 9. So my Quattro partition is used only 3.5 gigabytes. And the way this works is that the KVM virtual machine will not utilize the entirety of the space that you have predefined for the virtual machine, but it will only use as much as the virtual machine has actually spent. But you have told the virtual machine that it is able to basically you have given it 32 gigabyte hard drive, right? It's just that this 32 gigabyte hard drive is only taking 3 gigabytes on your actual system because it's not full. And if we switch to the guest, right? So the guest is using, well, VDA as a hard drive here. The disk dev VDA, right? And VDA is of the size 32 gigabytes, right? So that's our hard drive. And it is 32 gigabytes large. And on this hard drive, we have 3 partitions. I mean, three hard partitions. VDA 1, VDA 2, VDA 3. So that's our guest. And how much is it full? It is full. It is full 1.8 gigabytes, basically. Iceblade virtual hard drive for the KVM guest. Yes. Demlin Trap is asking, it's like ISO file as available storage memory. Not sure what you meant by that. I was just wanting to share that if you are unsure about how large the hard drive is going to have to be for your guest in the long run, feel free to give it as big files, as big hard drive as you want. For example, your host has 1 terabyte hard drive. Okay, let's make it an easy number. Your host has 1 terabyte hard drive, and you are hosting 3 guests on your hard drive, 3 virtual machine guests, and you have no idea how big your guests are going to become in the long run. For example, you're hosting a PeerTube server which hosts a lot of videos, and videos tends to pile up over time. They take a lot of storage. And for example, for the PeerTube video server, you give it, let's say, 5 terabytes virtual hard drive. Immediately, you give it 5 terabytes. And for another server, you give it 1 terabyte. So now we have 6 terabytes. And for the third one, we give it, I don't know, 2 terabytes. So now we have 8 terabyte virtual hard drives on a 1 terabyte actual storage. This is fine. This is fine. It will work. All of the virtual machines will believe that they truly have as much space as you have told them, as you have tried to convince them that they have. They don't have any reason not to believe you, because you're the root, you're the boss. The only problem is that you have to pay attention to the actual storage. When it comes being near full, you have to migrate to a bigger hard drive, bigger actual hard drive, so that the guests can continue expanding. That's all. You just have to pay attention. This is easier than giving the guests small hard drive and later realizing that you need a bigger one, and then resizing the hard drive, and then resizing the partitions inside this hard drive. It's a lot of extra work that is completely unnecessary. So you just give it as much space as you believe they could need in their lifespan. You can just do that immediately. Unless you want to limit them truly, then of course, by all means, limit them to whatever you need. Target device for the hard drive on this image is VDA on the Virtuo bus. This configuration is actually really similar to mine. MAC address for the network card. Source network, that's the name of the networking device in the virtual guest that you have prepared in advance. I did not do the network. Net is by default, but for servers I need a bridge, so I made a bridge. Also Virtuo network card. Mouse is on PS2, keyboard on PS2, graphics of the type Spice. This file defines a number of hardware settings that are used by this guest, such as the amount of RAM that will have assigned to it, the number of CPU cores from the hypervisor that the guest will have access to, the hard disk image file that it is associated with this guest under the disk stanza, its display capabilities via the SPICE protocol, and the guest's access to USB devices, as well as emulated keyboard and mice input. One of the things that I wanted to say to you guys in chat is, while if you're not using shared RAM, you cannot over provision RAM, which means unlike the hard drive, you cannot tell the guest that it has 16 gigabytes of RAM if the host only has 8. You cannot do that. You have to tell, you have to give guests as much RAM as you, the maximum is the amount that you have available on the host, right? So if the host has 16 gigs like mine does, and your host system needs, let's say, 1 gigabyte in order to breathe, and you give your first machine like 4 gigabytes of RAM, then you only have remaining 11 gigabytes of RAM for the second machine. You cannot give the second machine more than 11 gigabytes of RAM because you don't have them. However, with the CPU, I have 6 cores on my CPU. I can give 6 cores to each one of my guests. Actually, I can give 12 cores to each one of my guests because my computer has hyper-threading. So it has like 12 virtual cores that are available. So if I have 10 virtual machines, I can give 12 cores to each machine if I want. But if I do that, then all of my 10 guests will compete for all of these 12 cores all of the time, which in some case is fine. But in other cases, it might not be such a good idea. This depends on how you want to design your virtual machines. Some virtual machines, you will want them to have certain priority, and some other virtual machines, you will want them to have a more limited scope of hardware access, so that they don't interfere with those that should have some priority, right? So it is on you how you want to design it, but CPU cores you absolutely can over provision, just like you can with the hard drive. Demlan Trap says, I mean that virtual hard drive is like I saw image in specific size on your. Yeah. Exactly. I didn't understand it from the first attempt. I thought that you were speaking about the over provisioning of the space, but you were just saying about one file being the image for the entire content, right, of the disk. Example virtual machine disk storage. This virtual machine hard disk image resides at var libvirt images RHEL 8. This is actually a default storage location for the images, right? But on my server, I have moved it elsewhere, and the reason is that my server has 120 gigabyte host SSD, and with 120 gigabytes, I cannot do much, really. So I added a second disk that is 4 terabyte SSD. This one will host virtual machines. It's on a different path, so I just changed the path to the images. So they did the exact same thing as I did, right? It says it is 5.5 gigabytes large, this image. I actually never used the LH switch. This is convenient. I always do the LA and then I count like how many of the bundles of 3 there are until I get to gigabytes or terabytes. Let's try LH. Very nice, very nice. 33 gigs. I'm gonna start using LH from now. The current size of this disk image consumes only 5.5 gigabyte of space on the hypervisor. However, the operating system within the guest sees 20. Why is it not the same? Why is it not the same on my end? This is inconsistent with with my readings. So their LH shows only 5.5 gigabytes, while the guest sees 23. But in my case, it's the same here as what the guest sees. What did I do differently than what they did? Where's the hard drive? Did I skip it? Image, disk. Disk type is file. Device is disk. Driver name. File. Might be dynamic virtual disk. Well, let's check it. Let's check it. Sudo vim pi-hole. Okay. Let's check the disk configuration. So disk. There we go. Disk type is file and device is disk. Actually, let's maximize this because we can't really read it side by side. Disk type is file, device is disk. Disk type is file, device is disk. Driver name QEMU, type QCOW2. QEMU, type QCOW2, and I also have discard equals unmap. This might be a key difference, but I'm unsure what this is. We're going to find out. Source file, target device VDA Virtio, and address type PCI, domain, bus, slot, function. Yeah, so this is the only difference that I can see. Discard equals unmap. The discard unmap option in KVM disk configuration is used to enable the trim command for virtual disks. This feature allows the guest operating system to notify the host that certain blocks are no longer in use, which can help in reclaiming unused space and maintaining the efficiency of the storage. To enable unmap, advanced option, change the bus to SCSI. So I think I get it, because the way I have it configured is when the guest has no need for storage, and when the guest does its trim command, then also the host will free up its space, right? Also the host will free up its space So when the guest does the trim command, this will decrease from 3.6 gigabytes to less. I think it's just the word trim or trim hard drive, trim space. Util Linux. Let's see. Let's test it. Let's test it for real. Util Linux. Is this installed? This is already installed. So to manually trim on a specific file system, use trim. To trim a specific mount point. Yeah, okay. So let's trim. Let's trim the root. 28 gigabytes trimmed. This is so weird. Okay, I have trimmed the guest, and let's run the df on the host again. So before trim, it was 3.6 gigabyte in use, and now it's 3.0 gigabytes in use. So it definitely did trim something. Alexei says he doesn't think so. He thinks that it just means that guest stream will be passed to the host. Yeah, this is exactly what we have just proven. But the reason why we even started doing this, Alexei, is because example virtual machine disk storage. It says here when the exercise is doing ls lh on the image, it says that it is 5 gigabytes large, but they have configured 23 gigabytes disk, but it shows up as 5 because 5 is in use. But on my end, I see the entire disk, no matter that it is only less than 2 gigabytes used inside the guest. I see it as 33. However, when I do the df, I can see only 3 gigabytes being used on my actual hard drive on the host. So it is not really taking as much as it says here. Oh, you mean lessability on the guest? There you go. Lessability on the guest, 30 gigs. It's probably a sparse file, but can I make my file to be dynamically increasing as theirs is? I would kind of prefer it if the file would appear as big as it is actually used within. I was kind of waiting for someone to give me something smart in chat. Daemon Trap, you can do the dynamic virtual disk in VirtualBox. Yeah, I know. You can do that in many of them, but I want to see how it is done in KVM. I mean, the image is already created, but it is 32 gigabytes big from the get-go, from the beginning. What confuses me is that the file system thinks that it is 32 gigabytes big, but when you see how much space is taken on the hard drive, it says 3 gigabytes. I'm happy that it says only 3 gigabytes, but why not make the file smaller then? So my configuration is QEMU QCode2 file. Yeah, my configuration is the same as this one. You can't convert to dynamic. It has to be made dynamic from start. Let's see. Okay, formatting, QCode2, cluster size, extended L2 off, compression type lib, size 20 gigabytes, lazy, ref counts off, ref counts bit 16. And the size of these, I see now. So this one is what I wanted. Alexis says sparse files don't really occupy their space. They grow as data is being written into them. So let's see. So what is better? What is better on two? Obviously, I have created a wrong type of image. This one is not dynamic. So is this better for performance or it doesn't matter? Because I prefer if the image grows in front of my eyes, right? This image also doesn't take up all of its. Daimler Trap thinks that fixed size is faster, but the thing is, this image also doesn't take up 33 gigabytes on my hard drive. Both of these images only take up as much space as they need. So does this one have any performance benefits over this format? Because this one is nicer to look at. What the hell am I doing wrong? But, oh well. Okay, so this one is 2.4 gigs, says disk usage. But why is this one claiming, but why is LS claiming 33 gigs? It's obviously a different setting for this file, I suppose. You know why I'm you know why I'm stuck at this right now, because the file size is 33 gigs, but it only occupies 2.4 gigs. Yeah, okay, I understand this, but the reason why I'm stuck on this is because I might prefer it if the file is not 33 gigs, but the file is actually dynamically expanding. You know, so Dale Anderson says maybe the utility implementation has changed since this chapter was written. Since it works better when copying them. Yeah. Copying is one of the reasons why I was concerned about this. And it's also nicer to see that the file is actually smaller. And I don't really think that I will have any performance degradation that I can feel. Okay, I'm going to redo my first virtual machine and reinstall everything. Unless it can be converted. Zoran is asking, using 2.4 gigabytes for Pi-hole, is that including an operating system within the VM? then I would choose to run it in a container instead of a VM. Yes, this is the entire operating system. Okay, let's give it a try. Let's give it a try. First, power off. Disk we don't need. Move pi-hole to pi-hole qcov. Call it old. Convert path to old file. And then path to new file. Okay. Let's just do the pi-hole. Voila. Done. Sorry. Okay. Now it is 2.4 gigs. Now it is 2.4 gigs. Okay, remove. Actually, let's start it first to see that it is actually working. Well, it is working. It is working, so we can wipe the old one by whole old. Okay. And now we have 2.4 gigs here. And the same disk usage as previously. And once again, we can SSH into our pi-hole, and we still have 30 gigabytes here. We still have 30 gigabytes, but now it's much nicer to look at, right? 2.4 gigs. Iceblade says kind of cool way of doing it without reinstalling it. I mean, in this particular case, reinstallation would not be a pain in the ass because pi-hole is like literally one command to install. But plus the operating system, right? But it's always nice to check if you can do it faster in some kind of conversion mode, right? It may be a better idea to read the actual documentation, but during the live stream, large language models are kind of helpful to get the answer a bit faster if they know it. I mean, outside of this live classroom, I would recommend actually reading the manual, because when reading the manual, you will also skim with your eyes on some other commands that may be interesting to you, and generally you might acquire a little bit more of the knowledge than just relying on someone else to give you the answers, which in this case is LLM. Alexis says you could create a new disk, add to VM, and use LVM live migration. Yeah, LVM, I made it LVM because I wanted to, in case the 30 gigabytes wasn't enough, I wanted to make myself, make my life. I mean, for Pi-hole, surely this will be enough. But, just in case, if for any whatever reason it is not, then this makes my life a bit easier in the long run, making it LVM. So where were we? Virtual machine storage. Okie dokie. So now we know that we can actually make it dynamic. The current size of this disk image consumes only 5 gigs of space. However, the operating system within this guest sees 23 gigs as evidenced in the lsblk within the virtual machine, right? And they also use the LVM. Okay. This is due to the type of disk provisioning used for this guest. There are multiple types of disk images that a virtual machine can use, but two primary types are copy on write, also referred to as STEAM provisioning or sparse images, is a method where a disk file is created with a predefined upper size limit. The disk image size only increases as new data is written to the disk. Just like the previous example, the guest operating system sees the predefined disk limit of 23 gigs, but only has written 5 gigs. The disk image format used for the example virtual machine is QCOW2, which is a QEMU cow file format. So this is what I still need to understand. How did I manage to create a QCOW2 file format and not make it as described here? A raw or full disk type is a file that has all of its space pre-allocated. For example, a 10 gigabyte raw disk image file consumes 10 gigabytes of actual disk space on the hypervisor. There is a performance benefit to this style of disk as all of the needed disk space already exists, so the underlying hypervisor can just write data to the disk without the performance hit of monitoring the disk image to ensure that it has not yet reached its limit and extending the size of the file as new data is written to it. There are other virtualization management platforms such as Red Hat Enterprise Virtualization and OVIRT that can make use of physical disk to act as backing storage locations for a virtual machine's operating system. These systems can utilize storage area network or network attached storage devices to write their data to, and the hypervisor keeps track of what storage locations belong to which virtual machines. These storage systems can use technologies such as logical volume management to grow or shrink the size of a virtual machine's disk storage as needed, and to aid in the creation and management of storage snapshots. One of the things that I have been somewhat considering is using my network storage as well, my storage for disk images for my virtualization server. But I was a little bit afraid of doing that because limiting my storage speed to 1 gigabyte per second is, I suppose, fine, but I don't know, my Atom NAS machine might not be exactly equipped with necessary power to handle many virtual machines running at once on the same ZFS storage. I think it would slow down my virtual machines by a significant margin. Virt Manager probably said this one. Yeah, I suppose you're right. My colleague from work is using the what is it called? The clicky interface for for storage. Kind of forgot what is the name. But anyways, he uses virtual machines on a remote storage machine while his virtual server is another machine, but his network connection is 10 gigabits per second. So and his storage is really fast. So TrueNAS, yeah, TrueNAS. He uses TrueNAS for storage, but as I said, his storage machine has 32 gigabytes of RAM, and it has a powerful modern Ryzen CPU, as far as I remember, and 10 gigs and 10 gigs connection between the virtualization server and storage server. So I think my setup is pretty weak for doing this over the network. There are other virtualization. We already read this, yeah. Working with virtual machine templates. Since virtual machines are typically just files running on a hypervisor, it is easy to create templates that can be customized for particular deployment scenarios. Often a virtual machine will have a basic operating system installation and some pre-configured authentication configuration settings set up to ease future system launches. This cuts down on the amount of time it takes to build a new system by reducing the amount of work that is often repeated, such as base package installation and locale setting. This virtual machine template could then later get copied to a new guest system. In this case, the new guest would get renamed, a new MAC address generated for its network interface, and other modifications can be made depending on its intended use. So what is this? What this is saying is basically, after, in my use case, after I would make my first machine, if all of my virtual machines will be Debian, I can just install Debian once and set it up. You know, the first step, set it up to creation, locale, install Vim, and you know the stuff that I will have the same on all of my future machines, just the basics. And then I copy this image as a template. And when I make a new virtual machine, I don't have to install Debian again. I just copy this machine and I just rename it, the name of it, uh, change the MAC address as it says here, and carry on from there, right? You prefer GNOME boxes as a much simpler UI for QEMU plus libvirt stuff. I didn't try GNOME boxes at all. I have no idea what that looks like. Del Anderson says, do you have time to share how you create the basic Debian images? Is it just DD or some other voodoo? No. You misunderstood, Del Anderson. You install Debian as your first virtual machine, and you do not install your target software on Debian. For example, my first virtual machine is Pi-hole, but if I want to create a Debian template, then I first install the virtual machine that I am going to use for Pi-hole. But before I install Pi-hole to it, I set up my Debian, I fully install it, and then I shut it down, and then I just copy its hard drive virtual file elsewhere and rename it to Debian template. And that's it. And then I go back to my installed machine, I turn it on, I install Pi-hole on it, and when I want to make a second one, I start creating a new machine. Yeah, you copied the guest template. Look, when you create your second machine, you go to new virtual machine, choose how you would like to install the operating system. So the first time you did it, you do the local installation media, so ISO image for the Debian installer, right? Or you just import existing this image. That's all. You just import existing this image and you power it on, and you're done in 15 seconds. In 15 seconds, you already have a machine running. GNOME boxes, Arch Linux GNOME boxes. So it's literally called GNOME boxes. Okay. GNOME boxes wants to pull a shitload of dependencies. QEMU audio dbus. Why didn't my my virtual machine manager pull all of these QEMU audio dependencies? Okay, before I decide whether I need all of this shit, and I just want to see GNOME boxes, I just want to feel it for a few seconds. Flatpak install GNOME boxes. There is no GNOME boxes on Flatpak. How come? FlatHub. It's just boxes. Okay. Welcome to boxes. Express installation, easy downloads, drag and drop. Download an operating system. The Red Hat Enterprise Linux. Install from file. Okay, can I connect to my virtual machine? Alexei, can you give me a quick heads up how to connect to my existing virtual machine server? These two options are not enough. I need a button to connect to my server, basically. You're using it locally? Yeah. Okay, GNOME boxes a little bit later. For now, let's continue with this. Working with templates. Okay, we have read all of this. The dbus machine ID. Many Linux installations will utilize a machine identification number generated at install time, called the dbus machine ID. However, if a virtual machine is cloned to be used as a template for other virtual machine installations, a new dbus machine ID would need to be created to ensure that system resources from the hypervisor get directed to appropriate guest system. The following command can be used to validate that a dbus machine ID exists for the running system. Okay, if no error message is displayed, then an ID exists for the system. To view the current dbus machine ID, run the following. Dbus. Is this within the virtual machine? Yeah. Okay. Okay. The string of text that is displayed is the current ID number. No two Linux systems running on a hypervisor should have the same dbus machine ID. The dbus machine ID is located at varlib dbus machine ID and is symbolically linked to etc machine ID. Iceblade, this wasn't ID of the hard drive, no. This is the ID of the entire machine, of the entire virtual computer, or the entire computer. Did I run that command on the host or guest? I ran it on the guest. We are on the Pi-hole guest here. And I got this ID. Changing this ID number on a running system is discouraged, as system instability and crashes are likely to occur. If two virtual machines do have the same dbus machine ID, follow the procedure below to generate a new one. So delete the machine ID, dbus, ensure the machine ID. In the event that a machine ID is not a symbolic link back to machine ID, then the machine ID will need to be removed. This is a good question. This is a good question that is worth checking out. When I do a new virtual machine from the Virt Manager, and if I import the existing disk image, will the Virt Manager change my machine ID? I believe it will not be able to change it, but it's not like I have tried. I'm just thinking in my head whether I should do it right now. Try to import existing disk image, right? The one that I'm using for the Pi-hole, and create a new computer and see if the new computer will get a new ID. I mean, let's give it a try and see what happens. If it will end up having the exact same ID, then we know the answer. Use this volume as a template. Is it a template? Import existing. Huh. This might not be an actual template. This might actually kill my pie hole. Let's copy it first, just to be sure. Okay, import existing image, and let's use the test image. Choose the volume, operating system, Debian 12, forward 2 gigabytes of memory, 2 CPUs, whatever. We are going to delete it later anyway. Test, customize. Let's say that I don't want to customize, like just finish it. It's being created and started. Zip is copy, yeah, copy file. It's not actually booting. Force off. Let's see where the problem is. CPU configuration. Memory boot option. Oh yes, so it's not using it as a template, it's actually using the file that we have given it. Network card. Oh, let's see the MAC address. This is also interesting. Does the MAC address B308 B308 and the pie hole has network card. Oh, it has changed. Okay, so the MAC address of the network card has already been changed. This is good. SCP is secure copy. It uses SSH to copy over the on another computer, and just SCP, this is local copy. Tablet, mouse, keyboard, sound, serial, channel, video, controller. There is no reason why this would not boot, I think. Let's see one more time. What are we missing? Oh, firmware BIOS. Oh, that's the problem. Force off. Yes. We need to change the firmware to UEFI. Where is that? Why can't we change it anymore? Test. Delete. Not delete the file. Okay, let's do it again. New virtual machine, import test Debian 12. Okay, so what we have learned, you need to always customize configuration before installation. Yeah, unless you want to risk not being able to customize it afterwards. So now we can choose UEFI, right? This is what it was missing. We can only change this while creating the machine. I suppose we can change it manually in the XML, but let's call this the correct way. The rest I think is fine. And begin installation. And now it's booting up. Linux cat, welcome in cat. Press any key. So it's kind of, no bootable option or device was found. Okay, I rushed it again. So Virtuo disk, hypervisor default, 32 gigs, Virtuo test, boot options, Virtuo disk, enabled boot menu. I don't know why it's not seeing it. Okay, so we are in the UEFI BIOS of the guest, right? So let's see where we have a problem. Boot manager. Well, this should be fine. Boot maintenance, boot options. I don't get it. Continue. Force reset. Were you not supposed to use the other QEMU UEFI? Well, let's check it out. Force off. During the configuration, right? But look, in the overview, it says firmware UEFI, right? So that's what I have chosen. And if you see on my Pi-hole, the one that works, this one is interesting. But I'm sure that when I was creating this one, it was just UEFI. Okay, let's do it again. No problem. No problem. Let's delete the machine again. Delete files. No. New virtual machine. Import. This is all a part of learning. Testing. Debian 12. Forward. Customize. And this one, right? OVMF code for MSFT. Okay. So now it's the exact same as on the Pi-hole. No bootable option or device was found. Maybe the UEFI, learning from experience, yeah. I suppose if I would use BIOS and install the operating system BIOS way, I suppose then it would work just like this, but I'm not sure what am missing here. Force off, yes, file, close, Debian, delete, delete, yes. Let's try, let's remove test. Oh, I have deleted it fully. Okay, nice. Let's try to shut down Pi-hole. And let's clone it. Test. Clone this disk. Storage is safe to share. No storage to clone. Storage is not clonable. No storage to clone. Sharing is potentially dangerous. Clone. Yeah, I want it cloned. Yeah, I want it cloned. Cloning does not alter the guest OS contents. If you need to do things like change password, please see the virt sys prep tool. Okay, we just learned something more. There is something called virt sys prep tool that will assist our cloning. But let's give it a try on this and see what it does. Okay, let's start Pi-hole. Open it. Okay, Pi-hole works, as you can see. Pi-hole still works. Now let's run test. Open it, run it. No bootable option was found. Okay, I'm kind of out of ideas here, and I don't want to drag this session for too much. Today, I really need to go to sleep, like, in 5 minutes. But let's finish the lesson in a reasonable frame time. Force this off. Yes. And we are going to learn how to clone stuff properly. Test, delete, delete. Yes. Okay. There is a possibility, but it's not finding the operating system. Isn't that a drive path issue? It's an issue where the UEFI is not finding a drive or an EFI partition or something. We'll get to the bottom of that, but I cannot do it today. Deploying virtual machines to the cloud. There are a multitude of infrastructure as a service. Kudos to whoever said this 2 hours ago. There are multitudes of infrastructure as a service providers available that run hypervisor systems and that can deploy virtual guest images for an organization. Practically all of these providers have tools in place that allows an administrator to build, deploy, and configure custom virtual machines based on a variety of Linux distributions. Many of these companies also have systems in place that allowed for the deployment and migrations of virtual machines built from within a customer's organization. When assessing a deployment of a Linux system in an infrastructure environment, there are some key elements that an administrator should be cognizant of. Never heard of this word. Cognizant means fully informed or aware. Okay. I mean, just why not just type aware of if it's the same? Computing instances. Many cloud providers will charge usage rates based on computing instances or how much CPU time your cloud based infrastructure will use. Careful planning of how much processing time applications will actually require will aid in keeping the costs of a cloud solution manageable. Computing instances will also often refer to the number of virtual machines that are provisioned in a cloud environment. Again, the more instances of systems that are running at one time will also factor into how much overall CPU time an organization will be charged for. This is actually fairly similar to my setup. It's just that my setup is really simple, but the fact remains I am remotely managing it, right? I mean, my setup is the simplest setup possible, but it still is a kind of infrastructure as a service, right? It's just that I'm servicing myself. Block storage. Cloud providers also have various levels of block storage available for an organization to use. Some offerings are simply meant to be web-based network storage for files, and others offerings relate to external storage for a cloud provisioned virtual machine to use for hosting files. The cost for such offerings will vary based on the amount of storage used and the speed of the storage within the provider's data centers. Faster storage access typically will cost more, and conversely, data at rest, as in archival storage, is often very inexpensive. Networking. One of the main components of working with a cloud solution provider is how the virtual network will be configured. Many infrastructure as a service providers will have some form of web-based utilities that can be utilized for the design and the implementation of different network routes, subnetting, and firewall configurations. Some will even provide DNS solutions so that publicly accessible, fully qualified domain names can be assigned to your internet-facing systems. So for those of you who don't know what fully qualified domain name is, this is basically this, lethub.org. This is a fully qualified domain name. It is basically a full address of the host from the DNS perspective on the internet, right? This is also a fully qualified domain name, www.linuxrenaissance.com. This is also a fully qualified domain name, shop.linuxrenaissance.com. The rest of the URL is irrelevant. This is a fully qualified domain name. Basically, a DNS has given it a name instead of IP. Yes. Yes. But not just the domain name, but the entire host name, right? Both the domain and whatever it comes in front. It can have more than just two dots. Whatever you can resolve via DNS. I wasn't really planning for a plug, but There are even hybrid solutions available that can connect an existing on-premise network infrastructure to a cloud-based infrastructure through the means of a VPN, virtual private network, thus tying the two infrastructures together. Securely accessing guests in the cloud. The most prevalent method in use for accessing a remote virtual guest on a cloud platform is through the use of OpenSSH software. A Linux system that resides in the cloud would have the OpenSSH server running, while an administrator would use an OpenSSH client with pre-shared keys for remote access. An administrator would run the following command: SSH keygen and follow and follow the prompts to create a public and private SSH key pair. The private key remains on administrator's local system stored in this folder, and the public key gets copied to the remote cloud system, the exact same method one would use when working with networked machines on a corporate LAN. The administrator would then run the following command: SSH copy ID to the cloud server. This will copy the public SSH key from the key pair just generated to the remote cloud server. The public key will be recorded on this path on the cloud server and set the appropriate permissions on the file. If there is only one public key, then the -i switch can be omitted, as the copy ID command will default to the public key file in the directory, typically the file ending with the .pub extension. Some cloud providers will automatically generate a key pair when a new Linux system is provisioned. The administrator will then need to download the private key for the new system from the cloud provider and store it on their local system. Note that permissions for SSH keys must be, this is the read-write for the owner and no access for the group and other. So just the owner can read and write to this file. And 644 for a public here. For a public key, this means read-write for the owner, just read for the group, and just read for everyone else. So for every one of you who got confused for what the hell this entire block of information is, first you will see this entire procedure step by step in my video tomorrow that I have already recorded. But if that's not enough, you might have noticed that I haven't been typing my password while I was logging into my server, right? So right now I am on my local computer, my local Arch Linux. And when I do the SSH into my Pi-hole, I type SSH and the IP address of the Pi-hole, and I press enter, and voila, I am logged into my Pi-hole. And the reason for this, why didn't it ask me for a password? The reason for this is this procedure here, generating key pair and copying my secure key to my Pi-hole Debian server. And after that, I can log in a more secure way than via the password without typing the password. So you get both the convenience of not needing a password anymore and the extra security that comes from shared keys, which is higher security than using the password. Dale Anderson says, seems counterintuitive to obtain a private key for your local machine from a cloud computer. You're not obtaining a private key for your local machine. This command is run locally on your computer, and this command generates your private key and public key on your local computer. And then you run this command to copy just your public key to the cloud computer or to any Linux computer. The word cloud is whatever, it's irrelevant. When they say cloud, they mean other Linux computer. So the SSH copy ID copies your public key to the destination Linux computer. And after that, the first time it will ask you for a password, of course, so that it can copy the file. But after that, you can log in to the destination computer just by presenting yourself with your public key, and the destination server will recognize you. Oh yeah, that's the computer that has access, and it will let you in automatically. Some cloud providers, it says the opposite. Yeah, I noticed that. Some cloud providers will automatically generate a key pair when a new Linux system is provisioned. The administrator will then need to download the private key for the new system and store it on their local system. I don't know about this. I have never done this procedure before. I have configured myself a remote access to another Linux computer previously in my life, and I have always did it this way. I generate it on my local PC from which I am accessing a remote computer, and then I copy my public key to the remote computer, and that's how I can access it. Maybe I can show it. Maybe I can show it to you if I want. If I want to connect from Pi-hole to the host system which is hosting Pi-hole, let's do that. SSH. Okay, so from the guest we are doing SSH into the host, right? And it doesn't have our information yet. So first time it will ask me for a password. So this means that we haven't set up our key pair because it is asking me for the password. Okay, so let's Control-C to interrupt this. So we are now on the guest again. We will do the key generation. You can just press enter here, and for the passphrase you can just press enter again. You can leave it empty. You can leave it empty again. It will generate a key pair. This command does have options, and you can complicate your key if you want to make it more secure. But by default, it is fine. SSH copy ID -i, how was it? -i public. Actually, you don't need -i. Just do the Dart at your destination user and your destination IP 99.10, and it is asking you for your password so it can copy. Okay, number of keys added, 1. Now try logging into your machine and make sure it works, right? So let's go do the SSH into our destination computer. Let's press enter here, and voila, we have now logged in without the password. It's that easy. And from now on until the rest of the days of these two computers, I will be able to log in as user Dart from my Pi-hole guest to my Dart user on the Pi-hole, not on the Pi-hole, on my virtualization server host, right? So you need to do that for every direction that you want to log in. If you want to log in from the host to the Pi-hole guest, you have to do it again for both directions. I believe you, Dale Anderson, and I can clearly see it in this PDF. I just didn't do it previously. By the way, also the virtualization manager, this program can access my remote server. But the way it does this, see details. The way it does this, it connects to my remote server over SSH. And one of the requirements for this to work seamlessly was to create the SSH key pair. Because if I didn't create the SSH key pair, then the virtual machine manager would nag me with passwords. And in order to even enable it to nag me with passwords, I would have to install some more software that would act as an intermediary between, well, for all of the password stuff. Basically, generating a key pair for the SSH helps me not to be bothered with the virtual machine manager and passwords and all of that crap, right? So I'm using SSH to reach the destination virtual server. Iceblade is asking, so the key is literally just like a key if you have it just walk in the door. Yeah, pretty much. This is pretty good analogy, yeah. It's literally a key in the door versus having a pin on your door, which anyone can input if they know the password. Anyone can type the pin if they know which one it is. But if you do the key thing, then nobody can enter the door if they don't actually have the key. And in this case, I have generated my key and I have told the destination system basically what the lock should be for my key. That's why it is more secure. So you can even tell your SSH server to completely disable the password access, so that even people who know the password cannot log in with the correct password, because you have disabled this entire system, so that you can leave only the key entry into your system, right? So if the potential intruder doesn't actually have the key, they simply cannot enter. This will, Del Anderson says, public-private key pairs. You both share the public keys with each other, which proves you have each other's private key, but you never share the private keys. Do you think it already works on the different direction? Let's check it out. It doesn't work in a different direction. Nope. It's asking me for the password. So you both have each other private keys, but it's not set up for the other direction. I meant public keys, but are you sure there is a public key from the destination server? I'm not. I think only the destination server needs to have the client public key. That's all. The client doesn't have the client only knows the fingerprint. Yeah, let's try to finish the lesson. I would love to dig deeper into this, but I really want to get to sleep. Big date for me tomorrow. This will copy the SSH key from the key pair just generated to remote cloud server. The public key will be recorded in the destination and set the permission. Yeah, there is no mention of the remote public key being copied over locally. A useful tool that simplifies the deployment of cloud-based virtual machine is the cloud-init utility. This command, along with associated configuration files and predefined virtual machine image, is a vendor-neutral method for deploying a Linux guest across a plethora of infrastructure as a service providers utilizing YAML, plain text files. An administrator can pre-configure network settings, software package selections, SSH key configuration, user account creations, locale settings, along with a myriad of other options to quickly build out new systems. Okay, this kind of sounds useful when you're doing a lot of configurations, a lot of virtual machines. During a new system's initial boot up, the cloud-init will read in the setting from YAML configurations files and apply them. This process only needs to apply to a system's initial setup and makes deploying a fleet of new systems on a cloud provider's platform easy. The YAML file syntax used with cloud-init is called cloud config. There is a sample cloud config file. Time zone, host name, the name, update the system when it first boots up, update true, upgrade true, install the Nginx server packages that needs to be installed after the system is installed. Note that on top line there is no space between the hash symbol and the term cloud config. Cloud-init is not just for virtual machines. The Cloud-init tool suite can also be used to pre-configure containers, such as LXD Linux containers, prior to deployment. Okay, so the containers part. Container technology is similar in some aspects to a virtual machines, where you get an isolated environment to easily deploy an application. Whereas with virtual machine, an entire computer is emulated, a container uses just enough software to run an application. In this way, there is far less overhead. Containers allow for greater flexibility over that of a virtual machine. An application container can be migrated from one host to another, just as virtual machine can be migrated from one hypervisor to another. However, sometimes a virtual machine will need to be powered off before it could be migrated, whereas with a container, the application is always running while it is getting migrated. Containers also make it easy to deploy new versions of applications in tandem with an existing version, as users close their sessions with running containers. These containers can get automatically removed from the system by the container orchestration software and replaced with the new version, thus reducing downtime. There are numerous container technologies available in Linux, such as Docker, Kubernetes, LXD, systemd, nspawn, OpenShift, and more. The exact implementation of a container software package is beyond the scope of this exam. Containers make use of the control groups, better known as C groups, mechanism within the Linux kernel. The C groups is a way to partition system resources such as memory, processor time, as well as disk and network bandwidth for an individual application. An administrator can use C groups directly to set system resource limits on an applications or a group of applications that could exist within a single C group. In essence, this is what container software does for the administrator, along with providing tools that ease the management and deployment of C groups. Currently, knowledge of C groups are not necessary for passing this LPIC 1 exam. The concept of C group is mentioned here so that the candidate would at least have some background knowledge on how an application is segregated for the sake of system resource utilization. I have Docker installed, obviously. Let's try Docker run Debian stable. Is that the command? No, it's not. Docker pull. Okay, then try pull. Permission denied. Yeah. So what just happened in merely 2 or 3 seconds is that I have ordered Docker to pull a base Debian container from some cloud server that hosts default Docker images, right? So someone else has prepared a Debian stable Docker image, and I have literally just pulled it in 3 seconds. Okay. Docker run Debian. Sorry. What did I do wrong? Login? I suck with Docker stuff. But we are going to learn. No worries. Let's like ask for some help. Docker pull Debian, Docker run IT. For interactive terminal access. Okay, so run IT. That's what I was missing. Docker run dash IT. There we go. Okay, so we are now inside the Docker image, right? So if you remember, I'm using Arch Linux, and I have now downloaded Debian Docker image, and we can do the apt update for our Debian. We can do apt full upgrade. There is nothing to upgrade. We can do vim. There is no vim. Apt install vim, and we can install vim in our Docker image, and voila, now we can do vim, right? So that's a tiny feeling on what Docker feels like, right? So the entire image that we have here is probably super tiny, right? And sudo docker yeah, so you can see that we have ran a Debian image about a minute ago, and within the Debian image we are running this command, right? And if we exit this Docker image, and if we type ps, Docker is no longer running any container because we have exited the container, and the container has no reason to exist anymore in terms of being active, right? There is nothing for this container to do, because the only thing that this container was actively doing, it was running bash, and that was all it was doing. And once you stop bash, there is no reason for this container to continue living, right? What you can do, you can do docker exec. How does it work? Let me see. Execute a command in a running container. Let's exec vim inside Debian. I think that's how it works. No such container. Okay, exec Debian vim. No such container Debian. Huh? I'm confused. It's giving me a lot more than I wanted to hear, but okay. I have overloaded the AI. So it didn't answer my question. It's giving me the same answer again. Okay, this AI is stupid. Anyways, the idea regarding the containers is usually you will install all of the requirements for your application, and when you have the application running, well, then you can give it to someone, right? You can literally be a developer of software like Pi-hole and give people Pi-hole Docker image, for example. Let's see if we can install Pi-hole in a Docker just like that. I'm not going to install it completely. I just want to see. How it feels. Pi-hole. Okay, so Docker install. They have a Docker installation method. Copy the Docker compose file. Automatic configuration. No, what I was wondering is, can I run the normal install command, this one here, to add it to my container without using their container? There is no curl. How is this possible? Okay, this will derail me too much. That was not planned. What CPU extensions are necessary on x86 based hardware platform that will run fully virtualized guests? Alexei says you'll need to build a container based on base container with Docker file. Okay. I guess it's study for another day, but thank you. Just noted the shaded commands in the terminal above your system tray. Oh, you mean this? You mean these here? These, Dale Anderson. These 4 guys here. Those are tabs. Yeah, those are tabs of my terminal. Just tabs. Iceblade says AMD V and X Intel something. Yeah. Okay. I would say that Iceblade has the first point here. AMD V. Yeah, AMD V and Intel. I kind of forgot as well, but yeah. A mission critical server installation that will require the fastest performance will likely use what type of virtualization? Mm-mm. Or maybe. Actually, I'm actually not sure what do they mean by this. But I think you have mistaken the entire topic, Iceblade. I mean, type 1 is faster, but I don't think that they are asking for that answer. When they say what type of virtualization, I think they want us to say para-virtualized guest, but maybe I'm wrong. You have fully virtualized guest, you have para-virtualized guest, and you have hybrid one. So the para-virtualized guest is the fastest one. And I think that's what they are asking. But if they were asking about type 1 and type 2, then Iceblade got it correctly. I mean, both answers could be related to the fastest performance, right? I'm just not sure what the question is referring to. But we will see. Two virtual machines that have been added per virtualization is kind of what I answered, right? We'll see. Two virtual machines that have been cloned from the same template and that utilize dbus are performing erratically. They both have separate hostnames and network configuration settings. What command would be used to determine if each of the virtual machines have the different dbus machine IDs? I'm not the best at remembering the exact commands before I practice them for a while, and then I tend to remember after a while, but not immediately. So this time I'm completely aware of what the question is and what the answer is. It's just that I forget the exact command. Something GUI and sure, yeah. Yeah, let's call it a day. It's good enough for an answer. Run the following command to see if your system already has CPU extensions enabled. To run a virtual machine. Your results may vary depending on your CPU. Okay, let's run it as they ask us to. Okay, so the result, we are grabbing VMX or SVM from the CPU information. And apparently our CPU info has VMX flags, 6 of them. So in each CPU, one VMX flag. No need to sudo. Okay. I thought it would be faster than making a mistake and then doing it again. Depending on the output, you may have VMX highlighted for Intel VTX enabled CPUs or SVM highlighted for AMD SVM enabled CPUs. Should you get no results, consult your BIOS UEFI firmware instructions on how to enable virtualization for your processor. Let's do it again on my, so this is clearly Intel CPU, right, on my virtual server. But let's go to my local computer. This one is AMD, so we should get SVM results, right? So there you have it. A lot of SVMs, right? Could be 16 of them or something like that. If your processor supports virtualizations, seek your distribution's documentation for running a KVM hypervisor. Install the necessary packages to run a KVM hypervisor. If you're using a graphical desktop environment, it is recommended to also install the Virt Manager application, which is a graphical frontend. It is this. That can be used on a KVM installation. This will aid in virtual machine installations and management. Download a Linux distribution ISO image of your choice and following your distribution's documentation, create a new virtual machine using this ISO. answers to guided exercise. So VTX for Intel and AMD for AMD. The mission critical server makes use of paravirtualization. And the reason for that is that a better use of hardware resources. Yeah, so the command was dbus with gen. The thing that we have all seen on my screen and in the PDF, and tried it and forgot the command. Answers for explorational exercise. The result will vary and you will get VMX. Okay. If your processor supports virtualization, so these are instructions where you will find the guide for the KVM on Arch, Fedora, and Ubuntu. And that's pretty much all. And the next weekend, we are switching to a completely new topic called 103. GNU and Unix commands. Boys and girls, we are switching to level 4 next Sunday. You might want to repeat this lesson before next Sunday, or at least read it once. Maybe read it just once on, I don't know, Saturday. Alexei says good night. Iceblade says good night. Dale Anderson says good night. Everyone says good night. I say good night. It's gonna be a harder one, not a hard one. No such thing as hard. Thank you very much, everyone, for hanging out. And see you in the video tomorrow.